Okay, this video is to go over homework packets 3A. So let's look at lesson 3.02, problem number 12. So let's read the problem. ACDF is a trapezoid. B is the midpoint of segment AC and E is the midpoint of segment DF. CD is 1 meter, BE is 2.75 meter. What is AF? So what is the goal of this problem? Goal is to find length of AF. Givens. So we can draw, or we can label it. We have trapezoid like this, which says A, C, D, F, and then we have a midpoint B on segment AC and midpoint E on segment DF. Okay, so we know that B and E are midpoints, right? That implies that AB is congruent to BC, so it should have the same length. What else do we know? We also know CD is 1 meter. And we also know that BE is 2.75 meter. Our goal is to find AF. Okay, so how do we do this, right? So let's think about, imagine that you have second copies of same exact thing. Flip it over and put it on the left side of it. So you'll have something like this. Right? So it's flip it over version of it, right? You see that? Now, do you see a parallelogram? Yeah, you see a parallelogram, right? Going AC and passing through D and go to this point, and then go down and go back to A. You see parallelogram. If this is parallelogram, this top segment and the segment in the middle and the segment at the bottom are exactly the same. Meanwhile, we know that this guy is exactly the same as CD, so that should be 1 meter, right? And also the one in the middle right here are exactly the same as BE. So that should be 2.75. And also this guy right there on the top one is exactly the same as AF. So those are the hints to find out the answers. Okay, let's move on to the next page, or page 3. Should say lesson 3.03. Problem number 4. I have to apologize that a picture didn't come out right, so you should have something like this. You have A, B, C here, and you should have D, E, F. Okay? So that's the picture. It goes like this. This has the triangle. So in triangle ABC, so you go ABC. You see the triangle right there? Right? E and F are midpoints. E and F are midpoints. Okay? E is the midpoint of BC. F is the midpoint of AC. And the area of triangle ABC is 30 square centimeters. What is the area of the parallelogram AB? ABIF, so this must be I then. So the goal is to find the area of parallelogram, right? The givens are, we know the area of triangle ABC is 30 square centimeters, right? So here's the hint. What do you think about the area of this triangle, BIF, right? I mean BIE, and the area of CEF, right? How do you compare that? I mean, is either the triangle is bigger or smaller or pretty much the same? But at the same time, we know that triangle ABC, the area of this guy is 30 square centimeters. So those are the hints to do this problem. Let's move on to page 4. Lesson 3.40, problem number 12. So it says the diagram suggests Noriko's method for cutting a trapezoid into a triangle. So you've got something like this, and you have something like this. Sorry, this is a trapezoid, so it should be parallel. You got an A, not this. This is not A. This is A, B, C, D. Now you got F here, and it says C prime and a B prime. So, A, what points on segment, it says answer questions to help her justify her method. So part A says, what points on segment CD does she need to find so that CF matches with segment DF? Okay, so what points on segment CD does she need to find? So can F be anywhere on CD, right? Or, in other words, F has to be in a certain point on CD. So that is the goal. Goal is to find where is F? Where must F be on segment CD? And those are the givens, right? So can F be somewhere over here so that you can draw a line like this, or right here so that it goes like this, or F has to be on certain points. So that's A. B says, will the edge from B to B prime be straight? How do you know? So if you draw that line, is this B prime from here to here? Does it have to be straight edge? How do you know? So in order to say line is straight, then we have to always make sure that any point has to have 180 degrees, right? So how do you know this B prime is 180 degrees, right? So that's the thing. Here we go. So we have F here. So now you know that. Well, we actually know some theorems about the angles, right? We know the vertical angles are congruent. We also know the PAI theorem. So what can you say about angle closed circle, this one? Well, you know what? Let's just go angle 1, 2, 3, and 4. What can you say about angle 1, measurement angle 1 plus measurement angle 2, right? We know measurement angle 1 is equal to measurement angle 3 by vertical angles theorem. Likewise, we know measurement angle 2 is equal to measurement angle 4, right, by vertical angle theorem, right? How can we use that to prove that B prime is straight line? Part C says, will edge from A to B prime be straight? So it's pretty much the same question, but here, this line. How do you know these are straight lines, right? So I want you to think about parallel PAI theorem, right? So we know that this is trapezoid, therefore we know that this BC and AD are parallelogram. I mean, not the parallelogram, parallel. right? So this angle 5 right there, let's call this angle 5, and angle, let's say 6, these are congruent by PAI. So this is part C, by the way. Equal to measurement angle 6 by PAI. Theorem, right? How about this guy, angle 7? Right? If angle 6, measurement angle 6 plus measurement angle 7 comes out 180 degrees, then we can say that segment A B prime a straight line. But how can you tell that measurement angle 6 and 7 add up to 180 degrees? Okay, let's move on to lesson 3.05. Problem number 5. Let's read. One side of the triangle has length 12. How long is the segment that joins the midpoints of the other two? So let's think about it. So what do we have to find? We have to find the length of the segment that joins the midpoints of the other two sides. So what are the givens? So we have a triangle with one side is 12. Okay? And we are talking about the segment that joins the midpoints of the other two sides. So that means this guy and this guy, right? So let's take the midpoints, and let's take the midpoint here, and let's join the segment as the problem says, right? How long is that? How long the midpoints? Okay, hints are, we know that this length is 12, right? If you cannot get that, you can look up the midline theorem. That's gonna give you a hint.